All right, hello and welcome to video for the Demo7. This will be a demo on the microprocessor with the extended ALU and the control path. So let's get right into it. Let's look at our select modes and let's do subtraction to start with, since that's where we're already at. And let's do 5 minus 3, so ROM 0 will be our A input, and ROM 2 will be our B input, and let's store the result in RAM 7. So here is our output address selector. Address A is going to be ROM 0, so I'm not going to touch that, and then our address for our B input will be ROM 2. So let's start. So we should have had 5 minus 3 is 2, and it looks like RAM 7 does have the number 2 in there. So let's take this RAM and make it our next B input, and let's do the remainder operation, which is 5. So 5 divided by 2 should give us 2 with a remainder of 1. And let's store that result in 6, RAM 6 down here. So we'll keep address A as it is, and we'll make the B input now 7. And let's run this and see if we get 1 in RAM 6. And looks like we've got that. Great. So let's look at how this works. The previous microprocessor did not have all this control flow. You normally had to manually pulse the clock and set the read or write. But here it's all automatically controlled with our control sequence up here. And we could select our different addresses with both the state that we're currently in, which is selected by here, along with our addresses that we could kind of pseudo store in these inputs. And then we have all this fancy logic over here that helps us select which mode we're in, which is where this D1 and D0 come from. We set the read mode, whether we're reading from the ROMs or the RAMs with this logic right here. And then we're writing to these RAMs, which also opens up this tri-state buffer over here and lets us write to the RAMs with this logic. And then we're clearing our registers, the stored B and the accumulator, with this logic over here. And then over here we're having which state we're in is whether or not we're loading B in or writing to the B store B register, and whether we're writing to the accumulator register. So let's look at where we got this logic from. So on the next page here, I have some Karnaugh maps along with the next state table. So let me pull that in closer so it's more legible. So up here we've got our next state table. So we've got the idle states, and if we're in idle mode we just want to stay there if we haven't pressed start. But once we press start, obviously we want to start the 4-state cycle of getting out of idle mode into the load B mode. And then once we've loaded B in, we want to load the the pseudo A register. It is a combinatorial circuit at that point for the ALU, so we're not really writing anything in, and we're doing the computation that we want. And then finally we're storing that in our second to final state before returning back to the idle. So here's all the different Karnaugh maps for we use D flip-flops for the state control. And then we've got our read, write, clear, the accumulator out, the demux Karnaugh map, all here. So Those are the K maps, but how does this actually work in tandem? So what you do is before you start, you would load up in your read-only memory what you want. You can't, or well, I guess you can start with a random access memory register down here, but when you turn on the computer to start with, they're all going to be set to 0. So unless you want to do an operation with 0, these probably aren't smart to start with. So you want to start with a read-only memory, which you could type in manually. And then you want to select your addresses with this address generator, which all it does is as the clock up here is counting up, it goes through each one of these addresses into the address decoder over here, which then, depending if we're in read or write mode, helps us select which of these units we're going to be talking about and whether we're reading from them or writing to them, obviously. Up here we've got the counter or state registers, which you need to press start to get into. And then what happens is once this counts up, we're going to first load in whatever registers from B up into this register. And then we're going to load A in to the ALU by switching this demux, and then the combination or the combinatorial circuit of the ALU is just going to do that calculation real quick. And then as we're switching into that mode, we're also writing or enabling the write to this accumulator. And once that calculation's been finished, the second to last state, the accumulator buffer, is going to be on along with the write mode to one of these RAMs down here, and we're storing that final output and then returning back to the idle mode right after until we hit start again. In the idle mode, the paths are either blue or red because we don't have anything loaded in, we don't have anything selected. And it's not until we start that everything starts working. But I believe that's everything. Thank you very much for watching and have a nice day.